Hydrolyzed mixture. Question 5. When fats and oils are hydrolyzed, mixtures of fatty acids are obtained. Name the other product obtained in this reaction. Okay, so we need to know what happens with fats and oils. Fats and oils all have the same basic structure. We have basically got this, and they're asking what is that, because these are the fatty acids you break here. So what we're looking at is propan 1, 2, 3 triol, or glycerol. Glycerol is probably the easier one to write down. Okay, table below shows the percentage composition of the fatty acid mixtures obtained by hydrolysis of coconut oil and olive oil. So we've got the class of fatty acids produced. We've got a lot more saturates in coconut oil than we do in olive oil, and we've got more monosaturates in olive oil and coconut oil, and we've got more polyunsaturates than we do in coconut oil. Okay, one of the fatty acids produced by the hydrolysis of olive oil is linoleic acid, C17H31COOH. State the class of fatty acid to which linoleic acid belongs. So we're trying to work out, is it saturated, monounsaturated, or polyunsaturated? Right, I think the easiest way to work this out is to recognise exactly what the structure is of a fatty acid. Right, so this is how I would kind of look for a general fatty acid. This would be a saturated fatty acid. It always has to have a CH3 on the end cap, as it were. It has to have the acid part, C double bond O bond O bond H, and it will have CH2 repeated quite a few times in the middle. Okay, so that means that you can have a general formula you can work from. So if I've got C17H31COOH, what I'm saying is, let me just get another colour. Okay, this one, this bit here, is here. So I'm going to take that out of my formula, as it were. Okay, and then I want to take out this one, because that then leaves me with C16H28. Okay, now I can look at it and say, do I have enough hydrogens for me to go CH2, 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 CH2? Because every 2 hydrogens that I'm down, what I've done is got rid of 2 hydrogens and made a double bond. Okay, so if I was going to get fully saturated, I would need it to be C16H32. I don't have that. I've actually dropped out 4 from that. So I have not just 1 double bond, I have 2, which puts me to polyunsaturated. It's quite a bit of work, and you do have to really understand the structure. Or your other option was you could have drawn the whole thing out, and if that was what you had to do, do that. Okay, hydrolyzed coconut oil contains the fatty acid caprylic acid with the formula CH3CH26COOH. State the systematic name for this. Okay, well, you can draw it out if you want to, but I would expect you also to be able to do the count. So we've got 1, 2, 3, 4, 5, 6, and C double bond O bond OH. And it maybe is good to draw it out so that you don't get caught, okay? Because what you might have done was go carbon and 6 carbons. That's going to give me my carboxylic acid at 7, but you've got to remember the other carbon. 1, 2, 3, 4, 5, 6, 7, and then the C and the C double bond O bond OH. So what we're actually looking at here is octanoic acid. Oh. And that's the biggest systematic name that we'll expect you to be able to do up at 8. Okay. C. The degree of unsaturation can be tested by adding drops of bromine solution to the oil. Bromine adds across the double carbon-to-carbon double bonds in the fatty acid chain, so that's just a straight bromine addition. Okay. Following apparatus can be used to compare the degree of unsaturation. Oh, okay, that's the right point. So we've got a burette with 0.02 molar bromine. You've got a conical flask with 0.5 grams, centimetres cubed of oil to be tested dissolved in hexane. Describe how this apparatus could be used to show that olive oil has a greater degree of unsaturation than coconut oil. Okay, so what we need to do is basically add bromine from this burette and stop when it stops being decolorized. So every drop should decolorize until it runs out of double bonds. Okay, so what we're looking for is titers for your bromine where it stops decolorizing. Okay, that's the first thing you would need to do, and that's your first mark, recognizing that's what you'd have to do. Then, because it says, how could you use it to show that olive oil has greater degree of unsaturation? Olive oil, oh, can't control my pen. Olive oil will take more bromine than coconut oil. And that's it. That's you actually showing this greater degree of unsaturation, and I've described how the apparatus should be used. Okay, so it's your 2 points on that one. Suggest why hexane is used as a solvent rather than water. Basically, we're trying to dissolve a fat, so hexane is going to be better because it's non-polar. And for solvents, we're looking for like with like. Water is polar, and so therefore would not dissolve it. Okay. We've got the last one. Coconut oil has a melting point of 25 degrees C. Olive oil has a melting point of -6. Give 2 reasons why coconut oil has a higher melting point than olive oil. Okay, so what we're looking for here is basically that we have more saturated chains, and that means that they can pack more closely, and that means you get more associations, and that means that you're going to take more of them to melt it, and that's what we're looking for. Okay, and that's the question.